Hello and welcome to the In-Cosmetics Formulation Summit talk on biotech and green chemistry and the better use of resources. My name is Kevin Gallagher. For those of you who don't know me, I enjoyed a long career at Croda, started in the industry as a formulation chemist and retired as the president of Global Personal Care and Actives. I've been involved in some of the important industry organizations like the Personal Care Product Council and the American Cleaning Institute. I currently serve as an independent board director at P2 Science and Inolex. You could see some of my background here. I'm very proud of the fact that I'm a fellow of the Society of Cosmetic Chemists, in addition to being a business guy, and received, quite honored to receive the Lifetime Achievement Award at the In-Cosmetics in Paris in 2016, as well as more recently the Industry Contribution Award from the World Surfactant Conference. If we're going to talk about green chemistry, for me, the touchdown and the place to begin is the 12 Principles of Green Chemistry, co-authored by Paul Anastas here on the left and John Warner on the right. 12 Principles laid out a broad um, set of parameters by which we can measure green chemistry and by which we can use to make improvements on how green our chemistry is. And I think that when we discuss green chemistry in particular, at least from my perspective, this really is the source and the place to go for our definitions. The 12 principles of green chemistry have certainly become part of the culture of chemistry, particularly here in the United States. The American Chemical Society, the ACS, offers a pocket guide you can download from their website. Likewise, if you go to the website and you go to the page on the 12 principles of green chemistry, it'll let you expand on each one, give you further definitions, give you some metrics that you can use to evaluate one material over another, and they'll go into it in some detail, which I can't really today in a talk where I'd like to give some examples of how the 12 principles are applied to ingredient chemistry. They've been around now since 1998, so we've had 20 years or so for these things to have become established in our business. Well, I think about the 12 principles of green chemistry in the context of ingredient alternatives and the trend towards ingredient alternatives in personal care. And I think we could see a lot of intersection here, right? And particularly with regard to safer materials, particularly with regard to renewable feedstocks, with regard to degradation, or stated in another way, biodegradability. Again, the word safer occurs, renewable, degradation, all positive attributes that we would associate with today's materials, and indeed part of what's driving the trend towards ingredient alternatives. When we think about the ingredient alternatives, I don't think this list here will come as much as a surprise to the people who are watching this. There's a lot of energy around these different categories for somewhat different reasons. And I'll mention some of these as we go forward, but certainly people are looking to replace materials like silicones and conventional preservatives and quats and petrochemical feedstocks with renewable feedstocks, maybe even a subcategory in renewable from non-sustainable to sustainable. And then there's a topic I'll kind of leave for later, which is fermentation versus chemistry and the idea of using biology as an alternative to chemistry for ingredient alternatives. If we take those ingredient alternative trends and we look at them, we can see that there's a number of green chemistry principles that are driving them, particularly with renewable feedstocks, but also with regard to the importance of biodegradability. And often it's not just a single principle in the 12 principles of green chemistry that are doing this driving. Often it's multiple principles. We could see some of these here in the table. And when I give the specific examples, I'm not going to try and be exhaustive and mention all 12 of the principles that apply to each ingredient, but I'll mention the ones that I think are probably the bigger drivers. And you'll see these renewable feedstocks, safer chemicals come up again and again. One area clearly where there's a lot of energy is the replacement of volatile silicones, whether that's voluntarily or whether that's because of regulatory requirements. Volatile silicones were found to persist in the environment and so became a material of some concern. This is an example of cyclopentasiloxane alternative, in this case from Innolex. They list the benefits on the left-hand side, including things like low viscosity and fast-spreading properties we associate with volatile silicone, as well as wet and dry combing improvements. The material is a combination of a triglyceride, in this case heptanoin, and a C13 to C15 alkane, but an alkane that's also renewably sourced rather than from petrochemicals. So we have a material now that has both renewable feedstocks and is biodegradable, unlike the cyclomethicone, and this is the Lexfuel WOW A material from Innolex. Another area of a lot of energy and activity in laboratories, perhaps in your laboratory, is the replacement of parabens and MIT and other kinds of conventional preservatives or microbicides with other alternatives. And these other alternatives tend to be based on something called hurdle technology, well known, practiced in the food industry, where instead of throwing in a microbiocide at the end, they will put in materials, often materials that are polyfunctional, that represent hurdles to bacterial growth, right? And the one I'll talk about here is a natural organic acid-based one based on capryl hydroxyamic acid, recently reviewed by the Cosmetic Ingredient Review Panel and given a safe as used designation. This is an organic acid, but unlike many of the organic acids that have been in use, this one is 99% undissociated at pH 7. And what that means is it's greatly superior to something like benzoic acid at neutral pHs. So you don't have to go very low on the pH as you do in the case of some organic acids to make it workable. Certainly the paraben and preservative alternatives are being driven by safer chemicals and chemistry, as well as renewable feedstocks and materials that are designed for degradation. This CHA technology shows up in the Innolex Spectrostat range. Another area that's becoming increasingly scrutinized is the area of quaternary conditioning agents. There's concern about these materials, again, either persisting in the environment or having microbiocidal properties, even if they're not intended to. This is an interesting alternative in that it's an amino-based aminolipid ester, not a quaternary, but it does have cationic properties, therefore positively charged, stays behind. Compatible with fatty alcohols. In fact, the lipid fraction is from fatty alcohols. Again, it has very good performance characteristics in wet and dry combing, and it can be used in both skin and hair care applications. It's so mild. Another formulation advantage is that it forms lamellar liquid crystals, particularly in the presence of fatty alcohols. Like a lot of materials these days, 100% bio-based content, part of the USDA BioPreferred program and Cosmos certified. Certainly examples of safer chemistry, as well as designing for degradation, as well as renewable feedstock. And this is one of the materials offered by Innolex under the name AminoSensial HC. Of course, it's not just about the ingredients that a formulator will use in a personal care product. Sometimes it's the ingredients that go into the ingredients. In this case, an aroma chemical that's used in fragrance. And this is an aroma chemical alternative to nonanol, which is the C9 linear aldehyde. Previously, this had been petro-derived. It has a citrus, rosy, you see floral kind of green odor to it. It's a nature identical material, but it's made from vegetable oil. It's allergen free, and it's made using a novel process, a novel, in this case, ozonolysis process that uses process intensification that gives us some of the other benefits listed in the 12 principles in green chemistry. So besides coming from renewable feedstocks, it's a fundamentally less hazardous synthesis process in the way that process intensification is used in the ozonolysis. It's certainly much more energy efficient than older methods and inherently safer chemistry. And this is a material that comes from P2 Science and is offered under the trade name Bio-Nonanol. And I just note here with a smile that Dr. Paul Anastas is a co-founder of P2 Science and of course is one of the co-authors of the 12 Principles of Green Chemistry. But it's not just the components in a fragrance. It can also be the things that we use with fragrances. So for instance, alternatives to fragrance vehicles, particularly alternatives to different kinds of solvents that might be used. And I think this is an example of a material that was developed. It's a polymer derived from citronellol in the sort of concept of like dissolves like. It's made from natural terpenes, obviously works very well with citronellol type fragrance materials. It's also a safe and mild emollient polymer as a result of its structure, and it gives fragrances not only a strong initial but also a control release. Inky name is polycitronellol. Again, it's a great example from P2 Science of a number of the principles. Besides renewable feedstocks, we see safer solvents and auxiliaries. In this case, it is a safer solvent or auxiliary. Making it this way reduces the number of derivatives. Polymer chemistry and additive chemistry in general is good for that, and it's designed for degradation, and that it's a readily biodegradable material sold under the trade name Citropol F. We also can have active ingredient alternatives. In my time, particularly in the last, I would say 5 years, we've seen a lot of interest in looking at more natural sources for bioactive ingredients. This is an example of a fully natural cosmetic active that comes from non-GMO corn. It's a unique form of phytoglycogen, has a unique structure and molecular weight. It represents an energy source for cells. It has some great anti-aging, moisturizing, hydrating, evening skin tone properties that's been recognized with a number of technology awards. Again, renewable feedstocks, we see this come up again and again. In this case, less hazardous synthesis, really more of an extraction process rather than a synthesis without derivatives. Again, designed for degradation, sold under the trade name Phytospherics from Mirexis. Mild surfactant alternatives. I think if there's a theme that's been running through surfactants and surfactant trends in the last 5 to 10 years, if not longer, is the idea of increasing mildness profile and having surfactants that are not only mild in and of themselves, but can also reduce the overall irritation from a surfactant system. This is an example of a functionalized alkyl polyglucoside, 100% natural derived, EO-free, mild, non-irritating cleansing, preservative and sulfate-free. You could see the free idea here coming up a lot. Allows formulations with excellent foam and rich viscosity. This is a citrate derivative that's 100% bio-based. You see the inky name here, again, lauryl glucoside derivative. Besides renewable feedstocks, readily biodegradable, it also part of the idea of designing safer chemicals. This is a very mild, non-toxic material in and of itself, made through very safe synthesis processes, and can be used, as I mentioned earlier, to reduce the irritation of surfactant blends offered under the sugar citrate name from Colonial Chemicals. Even botanicals, we think of botanicals as being natural, but there's different ways of obtaining botanicals. In this case, using an example of what's sometimes called superfluids, in this case from Salabia, using either subcritical water or supercritical carbon dioxide for extraction. Depending upon which of those you choose, you'll either get polar or non-polar components. It's a great way to be able to increase the active molecule presence in the final botanical extract. If you go water soluble, you get flavonoids and saponicides. If you go CO2, supercritical CO2, you're more likely to get the oil soluble actives like vitamins and carotenoids. Clearly a Cosmos compliant type process. Again, besides renewable feedstocks, safer solvents and auxiliaries designed for degradation. Again, energy efficient processing. These are sold under the Solar Green name from Salabia. We get now towards the idea that I promised I would try and touch upon during the talk, which is using biology rather than chemical synthesis. And in this case, it translates into using fermentation rather than reaction chemistry, right? And using culture and cultured synthesis processes. So biosurfactants, we can describe them in different ways. In this case, a biologically produced surfactant made via fermentation. Sophorolipids. It's a kind of cleansing foaming surfactant many of you have heard about. Again, GMO-free, 100% bio-based, palm and EO-free. Usually these use sugar or some kind of carbohydrate as the starting material, if you like, as the inputs for the fermentation. No Proposition 65 warning required. Actually, no chemical synthesis involved. The inky name is glycolipids. And again, besides renewable feedstocks, we're talking about inherently safer chemistry, or in this case, biochemistry, as well as a design for energy efficiency. These are sold under the FIRMA name from Locus Performance Ingredients. Well, if we think about the future, where does this idea of biochemistry go from here? And I would suggest that one way it will continue to develop is this idea of designer molecules from designer organisms, and that this could indeed be the next frontier. There have been people like the founders of the company I'll mention here, Ginkgo Bioworks, who identified DNA as the next information language. And that essentially uses yeast or bacteria that can then be used to create important materials for the pharmaceutical industry, like penicillin and insulin, as well as materials for the cosmetic industry. Well known that hyaluronic acid has been produced this way. Ginkgo Bioworks describes itself as the organism company. So again, they're not making the downstream derivatives, they're creating the organisms that can help somebody make a cultured derivative. And they refer to this as biology by design. Well, I want to thank you for your interest and attention in this short talk. And also thank you for your contributions to innovation. I imagine the people watching this will be formulation people and related technology people who have devoted their working lives to innovation in our industry. And I want to say thank you for that. You can feel free to reach out to me if you like to by email with something. If you don't want to ask a question at the end of the talk, I certainly welcome any questions that you might have today. And so with that, I will try and bring this talk to an end, and hopefully look forward to some questions.